Alright, so introduction to thermodynamics. So what exactly is it? So we know we have thermodynamics, which is the study of energy and its transformations. So this study actually began in the Industrial Revolution as a way to measure the heat, fuel, and work in steam engines. So the branch of chemistry that's going to deal with that is thermochemistry. It studies the science of relationships between chemical transitions that need heat and energy changes that involve heat. So in order to discuss thermochemistry, we have to know some terms and symbols. So we know that energy is the capacity to do work or transfer heat. Work with a lowercase w is the energy used against a force. Heat with a lowercase q is the energy transferred from a hot object to a cool object. So notice that energy will always travel in direction from high to low. So in this case, thermal energy will travel from a direction from hot to cool. It's similar to the principle of osmosis, in which water is going to move from an area of high concentration to an area of low concentration. Next, we have our delta T, which is equal to the change in heat or temperature. An important formula to note here is that Q is equal to mCs delta T. You might see CS as Cp, just so that it's the specific heat. So it's the heat required to raise the temperature of the unit mass of a given substance by a given amount, which is usually 1 degree. It does not matter if it is Celsius or Kelvin, so just know that if you're given a specific heat in Kelvin and your problem's in Celsius, you don't need to actually convert it with the 273.15 degrees, but you can just write your Cp in terms of the temperature measuring system that you're dealing with. So now let's discuss some forms of energy. Very exciting. So we know that kinetic energy is the energy of motion. We know that potential energy is the energy of position. And we know that chemical energy is the energy stored in the bonds of a compound. Some other forms are thermal energy, mechanical energy, electrical energy, sound energy, and many, many more. So what you'll notice about this is that energy can be shown in many different forms. It just depends on where it's found. But one thing that energy cannot do is be created or destroyed. So think of it this way, like, you know, all things have energy, so when you have that energy, you can transfer it from one form to another. So think of like the example of when you heat your house, like when you want to increase the thermostat or something. When you react natural gas with oxygen, you're going to convert chemical energy into heat or thermal energy. In this case, you're not actually creating the energy to heat your houses, like you're not bringing it out of nowhere when energy does not exist, but you're converting it from a chemical state into a thermal state. So you're just changing energy from one form to another. And the last thing to remember for energy forms is that the stability of a compound is going to depend on its potential energy. So less potential energy is going to be more stable, and that relates to the concept that energy is released when chemical bonds are formed and it is consumed when chemical bonds are broken. So think of it this way, it takes energy to split a bond. If you have things that are bonded together, they're going to tend to not naturally want to split apart, whereas when you bond something, that's going to take it to a happier state where it's more stable, so it's going to take less energy to exist in its bonded states if it's more naturally existing there. So when we discuss thermochemistry, we discuss it in units of energy. So our SI unit of energy is the joule, which is kilograms centimeters second squared. And we know that our kinetic energy is equal to 1/2 times mv squared. Another unit of energy that is not an SI unit, but it is also very commonly used, is the calorie. So the conversion factor between a calorie and a joule is that 1 calorie is 4.184 joules. We also have our kilocalorie, which is essentially the large calorie, the calorie with the capital C. It's 1 nutritional unit or 1,000 calories. So if you see like a bag of potato chips that says I'm 50 calories, that just is referring to a nutritional unit calorie. And so it just means that it's 50 times 1,000 of the small calories. And we know that a calorie that's something that's going to raise the temperature of something by 1 degree. So how do we discuss thermodynamics? So that's in terms of a system and its surroundings. So a system is an isolated portion and its surroundings are essentially everything around it. So there are 3 main types of systems. So first we have our open system. So a system is going to exchange energy and matter with its surroundings in an open system. Think of an open pot of boiling water where it's going to exchange both energy and matter with everything outside the pot. Second, we have a closed system in which a system will exchange energy with its surroundings, just energy, not matter. So for your chapter 15 equilibrium reactions, you will exchange energy with its surrounding, but not matter. Lastly, we have an isolated system. So in this, a system will exchange neither energy nor matter with its surroundings. So for this, I like to think of like a thermos with rice inside. So if you put some hot rice inside a thermos, you're going to conserve that thermal energy inside the thermos. So when you close the thermos, you're essentially just trapping all that thermal energy inside. It's not going to escape because that's the purpose of a thermos, to keep your food warm. You also have the rice particles inside. When you're closing the thermos, you mean that like none of the rice is going to like fall out of the thermos or spill or anything. So it's containing all that matter inside, and it's containing all that thermal energy as heat inside. So the system cannot exchange neither the energy nor the matter with anything outside of it. Another way that we can classify systems is how they're set up. So we have, again, 3 types of systems. We have our isothermic system, which is where temperature is kept constant. We have an isobaric system, where pressure is kept constant. And we have an isochoric system, where volume is kept constant. So that's essentially all I have for an introduction to thermodynamics. So if you have any questions, feel free to comment them down below. In the next video, we'll go over the first law of thermodynamics, as well as the concept of enthalpy and possibly some math calculations. So that's something to look forward to. I hope you guys enjoyed this educational video, and I hope you guys have fun with chapter 16. Very fun chapter. Very, very, very fun chapter. Thank you for watching. Enjoy your day.